welcome to Believers IAS Academy. In this video, we'll look at the topic our atmosphere. Now, recently in news, you might have seen that Richard Branson, who is a founder of the Virgin Group, has actually reached the edge of the space with his crew members in his mission Virgin Galactic Flight. Now, this happened before Jeff Bezos was going to do the same, he's expected to reach around 106 km in his space mission called Blue Origin. Now we see a kind of space race between corporates here. Similar thing we have observed between nations back in the 60s and 70s when it was between Russia and US. Now this event is a beginning of the space tourism that we are going to see in the future. But there are actually certain disputes regarding whether he has been to space or not. So that we will look at in this video. So first, and also related to that, we will be looking at the basics of geography. That's important for your GS1, which are the different layers of the atmosphere, which you can see in this figure. So firstly, we need to know what is the boundary of space. So the most widely accepted boundary is the Kármán line, that is 100 km above sea level. And United States actually uses 80 km as the cutoff point. So Branson's Virgin Galactic flight only reached up to 86 km, okay, which is not beyond the Kármán line, but it is above the 80 km cutoff point mentioned by the United States. And Jeff Bezos' Blue Origin mission, it is expected to reach in the coming days when it kick-starts. It's expected to go about 106 km high. So the Kármán line, you can see it in this diagram or map, like above Mesosphere, that's between Mesosphere and Thermosphere, you can see this Kármán line. So the Kármán line is it is often compared to the international waters. We know that beyond 200 nautical miles, that is your exclusive economic zone according to the International Law of the Seas. So International Convention of Law of Seas, beyond this 200 nautical miles, it is international waters and there is no national boundary beyond that. Just like that, beyond the Kármán line, there is not going to be any kind of national boundary. It will be free space. So we will look at the different layers of the atmosphere. So first of all, we have on the bottom near to the ground up to 8 km at the poles and 12 km at the equator. We have troposphere, and we have stratosphere going up to 50 km, and we have mesosphere, thermosphere and exosphere. And as a subset of thermosphere, there will be ionosphere too. Okay. So first of all, troposphere. So it is the lowest layer of Earth's atmosphere and 8 km at poles and 18 km. Sorry, it is not 12 km, it is 18 km. Now why is this difference? So there will be at the poles, it is only 8 km, right? So what happens at equator? There will be strong convectional current at the equators. So as a result, the atmosphere, the troposphere's extent will actually increase a little bit because of this convection, the presence of this convection current. That's why we have a difference when it comes to height. And weather change occurs within this layer. So all the clouds that brings you rain, all the important gases, all these things will be in this distance up to this 18 km extent. So that's why important weather changes will be occurring at this layer. And water vapor and meteor particles are also present here, and also temperature decreases with increasing height. So when there is insolation, the sun's rays hitting the ground or hitting any object, so after hitting it, that light energy is converted to heat energy, right? So the heating happens from the ground. So what is close to ground will be more hot. So as the height increases, the heat won't be able to reach. The heat will become less. So that's why as the height increases, the temperature is decreasing. And the tropopause is the line where that separates troposphere and the stratosphere. Okay, that you can see here. Troposphere and stratosphere, there's this line, right? That is called tropopause. And the next one is stratosphere. It is found above the troposphere and up to a height of 50 km from the Earth's surface, and it's very dry. I mean, there is no presence of water vapor or any other mature gases, and as a result, it is advantage for flight because all the clouds. So when you are going in flight, and if you have sit in the window seat side and look down, you might have often seen clouds below you, right? That means you are at stratosphere. Troposphere is below you. So this area is very dry, and as a reason, there is, when the flights are actually flying through this stratosphere, there will be less engagement with thunderstorm. There will be less turbulence. The flight journey will be much more smoother, and that's why stratosphere is used by flights to travel most of the time. And the ozone layer is also found in this layer, the layer that actually makes us survive, helps us survive, which absorbs UV radiation, that is present in stratosphere. And stratopause is a line that separates stratosphere and mesosphere. And above stratosphere you have mesosphere, and it is the coldest area because of the presence, there is a very thin air over there. Okay, and the carbon dioxide presence is also more. As I said, this layer is more cold, and it extends up to 80 km from the ground level, that is from the sea level. And the temperature drops with altitude. Okay, as you go up, the temperature will reduce. So at the end of mesosphere, you will have up to minus 100 degrees Celsius. And the meteors burn up in this layer. So you might be thinking, this area is very cold, and why the meteors are burning up here. So meteors, when they reach near the Earth, they are going through exosphere, thermosphere. No problem here because there are very less gases found here. But in mesosphere, you have more gases compared to these layers, and as a result, so these gas molecules are enough to cause enough friction, right? So as a result, these meteors will get heated due to the friction, and that is enough for them to get burnt. That's why meteors burn up in this layer. And mesopause is the line that separates mesosphere and thermosphere. Mesopause. Now the fourth one is thermosphere. This comes above mesosphere, and the range is up to 400 kilometers. Some say it's around 600 kilometers. And it reflects radio waves. Why? Why does it reflect radio wave? So due to the presence of ions. Now the subset of thermosphere is also called as ionosphere. So due to the presence of ions, these are charged particles, and they reflect radio waves. So when you send a radio wave to ionosphere, it's going to reflect it back to you. And this property of ions is used by us humans to communicate, to send radio waves between long distances. So that's how thermosphere is reflecting radio waves, or more precisely, to be more precise, ionosphere is reflecting radio waves. The temperature starts increasing with increasing height. Now there are presence of oxygen and nitrogen in this layer, thermosphere, and they will absorb the solar radiation and convert it into heat energy, and as a result, it will be very hot in thermosphere. But satellites are placed at thermosphere. Why? Because when these satellites, although they are present here, the pressure here is very low, and also the heat transfer between molecules will be very less. Okay, as a result, so there is no danger of satellites getting burned up or anything, so it will be fine. And aurora. Now when the solar when there is reaction between solar ions and the oxygen and nitrogen, there will be a phenomenon called aurora. Now it can be visible from polar areas and all. There will be a kind of visual it will be visually pleasing, and it will be nice to look at. There's a colorful presentation will be there when it comes to aurora. So this also happens in thermosphere. Now, ionosphere is a subset of thermosphere. It's lower thermosphere, and it consists of ions, and I've already explained to you. They reflect back radio waves. And this layer is defined as a layer of atmosphere of Earth that is ionized by cosmic and solar radiations. And just like I said, solar radiation, solar ions, and that will react with nitrogen and oxygen to form the aurora too. And between 80 and 40 kilometers above the mesosphere, same distance where the thermosphere occurs. So you can see this. So this area will also be called ionosphere. Due to the presence of ions, it's called as ionosphere. And then you have exosphere, the final range. So we consider it up to 10,000 kilometers from the sea level, and this is an area where all the air molecules are going to escape to the outer space. So the zone where molecules and atoms escape into the space is mentioned, and it extends from the top of the thermosphere up to 10,000 kilometers. So that's all about the atmosphere, different layers of atmosphere. So for more such videos, you can subscribe to our YouTube channel. You can also follow us on social media, Instagram and Facebook, Twitter, Tumblr, or even LinkedIn. You can join our Telegram channel where you're going to get access to all the kind of free materials that we are going to provide you. This will include current affair, editorial analysis, videos, even infographics, mind maps, and so on. Even quizzes, everything you can access. And do visit our website where you will get to see the kind of course structure that we provide you, the materials, the NCERT books. You can download anything for free. And also you can contact us at info@believersis.com. Also you can fetch our contact details from our website and call us regarding any UPSC civil services exam guidance that you require. So that's all about it. Thanks for watching the video.